The moment this tiny mechanism contracts, when you pull it, shrinking as if snatching itself back, is nothing short of uncanny. Picture it. You tug on it, expecting it to stretch and give, but instead, it yanks backward. This goes beyond surprising. It feels like bending reality. That feeling prickles our curiosity, makes us ask, what in the world is going on? It's a perfect opening twist to stop the scroll and make viewers lean in. Under a controlled setup, a little cup is suspended from the mechanism. Add water drop by drop, and suddenly the cup leaps upward. It's a subtle pop, barely noticeable in magnitude, but the physics behind it is staggering. It flirts with impossibility, whispering, how? This defiance of what seems logical draws viewers into deeper questions. What unseen forces are at play? As we zoom deeper, you'll see this isn't just toy physics. The same paradox governs everything from mechanical constructs to the tiniest ecosystems, even sprawling city traffic and complex power grids. And the magic lies in a deceptively simple question. If we cut this green rope, what happens to the weight? Does it sink? Hover? Rise? That question alone builds suspense. It teases an answer that directly contradicts intuition, perfect for maintaining emotional tension. When you're handed the rope cutter, your mind races. Nothing will change, you think. Yet the experiment unfolds in slow motion. The slack ropes remain slack, but the cup doesn't plummet. It rises as if drawn skyward by a hidden hand. That's the moment curiosity peaks, and that aha feeling hooks viewers deeper. What's going on? You see, two springs are linked in series, sharing the weight equally. With one rope under tension and others slack, cutting the tension makes the system reconfigure instantly. The springs shift from series to parallel, halving each spring's extension. Two springs that individually stretched by X now rest at X equals 2. But because they're parallel, the combined system shortens. The weight rises. A seemingly magical transformation triggered by severing a humble green string. That's visual storytelling gold. Then comes the thematic shift. This paradox isn't just about ropes and springs, it's about networks everywhere. It surfaced first in traffic studies by mathematician Dietrich Braess in 1968, later gaining real-world validation in 1990 New York City. When Manhattan closed busy 42nd Street for Earth Day, fear of traffic chaos loomed. Instead, cars vanished and flow improved. Less infrastructure yielded more efficiency. This unexpected payoff builds emotional contrast and broadens the concept dramatically. What seems the obvious solution isn't always the optimal one. We step into Braess's thought experiment. Two symmetric routes across town, each composes a fixed highway and a load-sensitive city street. With balanced traffic, travel times are equal. But when a shortcut is added in the middle, drivers all flood it, congestion spikes, and everybody ends up slower, thanks to self-maximizing behavior. Removing the shortcut improves flow again, a mirror to the spring paradox. The reveal is delicious. Selfish individual choices can degrade collective outcomes. That insight resounds deeply because it touches on human behavior and societal dynamics. A story hook that's both cerebral and emotional. Then comes the kicker. This phenomenon transcends cars. It affects electricity grids, food webs, blockchain protocols, even the internet. Adding connections can destabilize systems just as easily as shortcuts can wreck traffic. We're confronted with a provocative takeaway. More isn't always better. In a networked world, restraint can be the smartest strategy. At this point, the narrative pivots personally, bringing it home by revealing how our own digital footprints expand networks of data brokers. After an unsolicited email promising to boost growth, justifiable hesitation came a torrent of spam once you replied. That's your real-life Braess moment. Ask for more, get deluged. Enter Incogni, a tool that cuts those hidden data ties, removing personal information from broker databases. Within 6 days, they issued 49 removal requests, 33 completed, and reclaimed 24 hours of time. Suddenly, the viewer sees parallel. Cutting the green rope in their personal data world makes them feel lighter, cleaner. That emotional payoff drives urgency. You want this. You then introduce the offer, 60% off via Incogni with a reminder, it's not just for you, but for your family too. That emotional appeal, protecting those you care about, cements engagement. Call to action, QR code, direct link, no hesitation allowed. Just when viewers think the lesson's over, you surprise them again. Mathematicians have replicated this counterintuitive contractive effect mechanically at the AMOLF Institute. The team built a mechanism that actually shrinks when pulled, a true counter-snap. You visit the lab, and on camera, the device responds like an angry living thing, snapping when prodded, tugging fiercely back. This visual climax ties back to the opening, delivering a satisfying, full-circle moment, while leaving a sense of wonder, accomplishment, and emotional resonance. Finally, you explain the science of snapping. Traditional systems collapse suddenly under force, but this flips the script. A combined state topology allows reversible switching between series and parallel, enabling you to manipulate natural resonance without changing length, doubling natural frequency with a light tap. It's a lucid ending punch, a high-tech application of a simple paradox, with potential future uses in vibration control, structurally adaptive materials, even balloons that deflate when inflated. In this structure, every paragraph rings with curiosity, tension, emotion, or payoff. By continually pivoting between surprise and scientific insight, you keep pacing brisk, curiosity piqued, and viewers emotionally invested in both abstract paradox and personal stakes, making it virtually irresistible to stop watching before the fascinating